Good afternoon, class. We are looking at Calculus 1, Exam 2 review, Chapter 3, Differentiation Rules. Exam 2 covers from 3.1 to 3.8, and here's section 3.4 to 3.5. 3.4, the chain rule. 3.5, implicit differentiation. The chain rule, section 3.4. The chain rule, how would you differentiate composite functions? Example, y equals square root of 10x plus 5. F of x equals 10x squared minus 1 to the power of 50. We use the chain rule. If g is differentiable at x and f is differentiable at g of x, then the composite function f of g of x is differentiable at x. d dx of f of g of x is f prime of g of x times g prime of x. I want to make sure we understand what that means. Differentiate the f, the shell function, the outer function, with respect to the inner function, and then times the derivative of the inside. This is the part that makes it a chain rule. As far as the Leibniz is concerned, and Leibniz and his notation, if y is a function of u, f of u, and u is a function of x, g of x, the y dx is dy du, du dx. So let's put this from A to Z. Capital F of x represents f of g of x or f of g of x. Capital F prime of x is the derivative of that composite function. And that is simply f prime of g of x, the shell, the outer function, we differentiate it times g prime of x. What we are looking at, remember the power rule, x to the power of n, if you want to differentiate is n x to the power of n minus 1. Now we're going to look at the general or extended power rule. If instead of x, you're dealing with g of x to the power of n, just following the method, n becomes the coefficient. X to the power of n minus 1, in this case, g of x to the power of n minus 1, so far is the same. And this part now says the derivative of the inside. Class, what is the derivative of x? 1. We don't have to write it. What is the derivative of g of x? Is g prime of x. So in essence, we really follow the same methodology here, but the derivative of x is 1. We don't have to write it. Now, if we could follow these examples, they will help us understand the concept. So this is sine of 2x. So that means sine is the shell function, the outer function. So the answer is cosine. But cosine of what? The same argument. By the chain rule times the derivative of 2x, which is 2. We put it in front. This is how it works, everybody. The next one, sine of x squared, again, y prime is cosine, and of course you need the same argument times what? The derivative of x squared, which is 2x, and we put it in front. The last one, we should recognize this as sine x to the power of 2. And now we use the extended power rule that says y prime is n, that means 2. G of x to the power of n minus 1, that means sine x to the power of 2 minus 1 times, now g prime of x is the derivative of sine, which is cosine, and we get 2 sine x cosine x. It's very straightforward, and I believe those examples will help us see what we should do. Okay, so it's y equals sine 2x, cosine 2x times 2. Sine x squared, cosine x squared times 2x, of course, we put the 2x first. And this is sine to the second power, so 2 sine x, cosine x. All right, let's move on. Y equals u to the power of 5, or f of u, and u is 10x cubed plus 2, or g of x. And we are going to differentiate this, and I want to show you two different ways. I'm going to go with the Leibniz's notation. dy dx is dy du du dx. So what is dy du? You are taking the derivative of this with respect to u. That means u is your independent variable. That means 5 u to the power of 4. What about du dx? Well, take a look at u. This function, you want to differentiate it with respect to x, you get 30x squared. So the answer is 150 x squared times u to the power of 4. So replace the u with 10x cubed plus 2. And put the 30x squared in front, you get 150x squared times 10x cubed plus 2 to the power of extended power. In essence. Now, this is easy enough. We can find the composite function f o g, which means y equals 10x cubed plus 2 to the power of 5. This is u to the power of 5, replace the u. And now to differentiate this, we are going to go with the extended power rule. 5 sits in front. So we're going to go with f prime of g of x times g prime of x, which means 5 sits in front. Then times the same function, 10x cubed plus 2, but to the power of n minus 1. So make it 4. And finally, g prime of x. What is the derivative of the inside? 30x squared. And now, of course, you put this next to 5, and you get exactly what you have here. There's no difference between the two. Okay, everyone? Differentiate y equals 4 square root of over square root of x squared plus 3. We are going to rewrite this. We are going to use our algebraic techniques. If you look at the exponential rules, and we are familiar with all of them, when we have a negative exponential, we can take it down. A to the power minus n is 1 over a to the power n. If it's down there, we can bring it up. This is x squared plus 3 to the power of 1/2. Bring it up becomes negative. So I'm assuming this algebraic step is a piece of cake. And now we are going to follow the extended power rule, everybody. So 4 doesn't go away, it's there. N is negative 1/2 times negative 1/2. Then the function x squared plus 3, we are going to subtract 1. So we write the same thing. Minus 1/2 minus 1 makes it negative 3/2. And finally, g prime, the derivative of the inside 2x. I want you to pay attention to the steps that we are taking here. And this is it. We're done with calculus. We are going just to rewrite this. Okay, everybody? And to rewrite this, first and foremost, this is what? 2 negative. With 2x, we get negative 4x. In other words, class, the product of a 4 negative 1/2 2x is negative 4x. And now this, we can rewrite it in this format, negative 4 over x squared plus 3 to the power of 3/2. And we put it in the same format, radical format that we had here, okay? Let's look at this one. One thing I want to tell you, anytime you want to differentiate trigonometric functions, read it and pause. So I'm going to read this as follows. I'm going to say cosine, ignore that for a moment, and pause. Cosine. The derivative of cosine is negative sine. But any trigonometric function must have an argument. In this case, the argument is whatever you see here. So we need that. And now by the chain rule, we tag along this one, okay? So in other words, we go here. And so the derivative of 3t to the power of 4 is 12t cubed. And that we put in front, we are done. So let's quickly recap. If you're differentiating a trigonometric function, just pay attention to the function, pause, you don't have to even look at the argument, you say cosine, the derivative is negative sine, then you need the argument, of course. And then the derivative of the argument, in this case 12t cubed, and you put it in front, and you're done. We want to differentiate this using the extended power rule. Notice something to the power of g, you can think of it as g of x, and follow that. However, anytime you have a fraction, the very first question is, can I simplify? Notice this is x, this is plus 4, and the reason you want to do that, you don't need to use a quotient rule. So according to the extended power rule, n, so 6 in front, the function itself to the power of n minus 1, so the function itself x plus 4 to the power of 5, and then g prime. The derivative of the parentheses happen to be 1. If you don't like it, if you don't write it, makes no difference, but write it to be on the safe side, and of course, you're done. However, When we look at part B, it cannot be simplified. So the first question, can I simplify a fraction? If not, then I move on. Because I can't, I'm going to use the combination of a extended power rule or the chain rule with the quotient rule. So in this case, something to the power of 5. I'm looking at this case. So 5 sits in front. Then the same thing to the power of n minus 1. That means 4. And I want to take the derivative of the inside. This piece I require the quotient rule for. So for this parentheses, I'm going to call the top the f function, the bottom the g function. So I need f prime g minus g prime f over g squared. So I have a fraction bar. F prime, the derivative of the numerator is 2 times the bottom is x minus 8 minus g prime, the derivative of the bottom is 1 times the top, 1 times 2x plus 3, and then you just write the bottom, x minus 8, and you square it. In other words, this part, you have f prime g minus g prime f over g squared. And so I'm going to erase that because I need the space. We are going to simplify the numerator of this last fraction. Which is 2x minus 16 minus 2x minus 3. As you can see, these two cancel each other. We get negative 19 in the numerator. So what we have is as follows. We have 5. We have 2x plus 3 to the power of 4. We have negative 19 in the numerator. The denominator is x minus 8 to the power of 4, x minus 8 to the power of 2. I'm going to rewrite it in this format. So you can see this one is like this one, and therefore, for the denominator, we have x minus 8 to the power of 4 plus 2, which is 6. For the numerator, we have 5 times negative 19, which is negative 95, 2x plus 3 to the power of 4. You don't have to write this step. You can go to the final one. I hope you can see that. Okay. And you have to check and recheck. So one more time. We are following the extended power rule. So 5 sits in front, g of x, the parenthesis, the power of 4, and then g prime of x. The derivative of the inside follows the quotient rule. When you do that, all you have to do is simplify the numerator and combine 5 and 2x plus 3 to the power of 4 and negative 19. It gives you this. Combine x minus 8 to the power of 4 and x minus 8 to the power of 2. 4 and 2, they add up to 6. So that's very straightforward, everybody. All right. The derivative of e to the power of x, it's a very powerful function. It is itself. Okay. And we know the derivative of f of g of x is f prime of g of x times g prime of x. Therefore, if you want to take the derivative of e to the power of g of x is itself, and then times g prime, this one is by the chain rule. If it happened to be e to the power of kx, then it's e to the power of kx times k. So if I want to differentiate this, everybody, first, I'm going to do this 2 steps. You don't have to do it in 2 steps, but I want to make a point. My point being, the moment I see an exponential, the answer is itself. I just don't look at anything else. The answer is itself. Then I see if I need anything else. When I look at the exponent is a function of t, so I need its derivative, so that makes it 5. Or you can go with this one. Of course, put the 5 in front, and you're done. For e to the power of tan x, the answer is itself, because it's e to the power of something, right? However, according to this, we need the derivative of tan x, which is secant squared x. So y prime is e to the power of tan x times secant squared x, and you don't have to bring it to the front, doesn't make much of a difference. Now part C is very straightforward. However, what I want to do in case there is a misunderstanding, this means a 2/3 x. So the answer is itself, and then times the derivative of this expression, which is 2/3, and I put the 2/3 in front. Y equals 2x squared plus 9x plus 9 over x plus 3. We are dealing with a fraction. We want to differentiate. And the question is, do we use the quotient rule? And the answer is, first and foremost, check. Can we simplify? Now, if we can simplify, the numerator must have a factor of x plus 3. Otherwise, we can't, right? So we give it a shot with x plus 3, and it does have a factor of x plus 3. Doesn't have to, but if it does, makes life easy. And obviously, you should know the derivative of 2x plus 3 is simply 2. Very simple and straightforward, everybody. All right. We know how to differentiate those. However, what happens in part D, the base is not E. What do we do? Well, to do that, we are going to remind everybody of a couple of logarithmic properties we've learned. ln of e to the power of x is x, e to the power of ln x is x, because the exponential functions and logarithmic functions are inverse functions. They have the same base, in this case e. And that's why ln of e to the power of x and e to the power of ln x undo each other, they give us x. So with that being the case, we are going to change this base such that the base is e, and using this concept, if e to the power of ln x is x, that means e to the power of ln 10 is 10, that means e to the power of ln b must be b. So we are going to replace the b with e to the power of ln b and raise it to the power of x. By the power rule, e to the power of ln b times x. Remember, ln b is a number, everybody. And so you have to multiply these two. So it becomes e to the power of ln b times x. The reason I put this in the parentheses, because this, if it's not in the parentheses, one may read it as ln of bx, which is not true. It's ln of b times x. And ln b is some number, like 5, for example. Imagine it's e to the power of 5x. The answer is e to the power of 5x times 5. But it's e to the power of ln bx. So e to the power of ln bx times ln b. Okay, I'm looking at this one. This is just identical to this conceptually. Look at this. This one is identical to this one conceptually. So we write the same thing, we multiply it by k. We write the same thing, we multiply it by k. This is k. And so if e to the power of ln b is the same as b, we are going to replace it, and we get b to the power of x times ln b. Therefore, what does it mean? Well, if the base is not the same, if it's e to the power of x, the derivative is e to the power of x. But if it's b to the power of x, is b to the power of x times ln b. This ln b is by logarithmic properties. So this is 3 to the power of x. The answer is itself. Is the base e? No. So we need natural log of the base times ln 3. And when we rewrite it, we better keep it in essence the same, because if you put it in front of this, one may think it's ln of 33 to the power of x. So this is good. What if it has a function just like the previous one? You're looking at the chain rule. So b to the power of f of x gives you itself ln b by logarithmic properties f prime by the chain rule. So you see 2 to the power of 7x, the answer is itself. Is the base e? No. So ln2. Is this x? No, it's a function of x. So the derivative of that, which is 7. So this is because of logarithmic properties. This is because of the chain rule. We rewrite it in this fashion, and we are done. Again, we put this in a parenthesis. We keep it in a parenthesis because we don't want anybody to think it's ln of 22, okay? Example 16. Observations show that the length L in millimeters from nose to tail of a Siberian tiger can be estimated by the function L equals 0.25 W to the power of 2.6, where W is the weight of the tiger in kilograms. Furthermore, a young tiger's weight can be estimated in terms of its age, T in days, by the function W equals 3 plus 0.21 T. How long is the tiger when it's 100 days old? Well, just the way it is, you can put the t here, find the weights, put it here, find the length, or you can find L as a function of W and move on. We're going to do both ways. But for now, first plug in 100 here to find the weight. This is 21, everybody. With 23, you get 24. And you put it here. You put it into a calculator. And 969.369 millimeters. Everybody remembers 1 meter is 100 centimeters, or 1,000 millimeters. So this is almost 1 meter. It's not, it's almost. So this is elementary algebra. Now this is calculus. At what rate is the length increasing when it's 100 days old? 1 point in time, that means instantaneous. Now, again, we have two ways. I want to go with the Leibniz's notation, and it says dy dt is dy du dt. So I'm going to write dl dt. At what rate is the length? dl is increasing when it's 100 days old. That means time dl dt. And I'm going to write it in this fashion because you have to find an intermediate variable. L is a function of what? And that is a function of t. It's a function of what? The weight. So we're going to put dl dw dw dt. So this is how you find it. Okay, L and t. What's in between? W. Now, what is dl dw? That means take the derivative of this piece with respect to w. So 0.25 remains times 2.6 w to the power of 2.6 minus 1, or 1.6. So this is dl dw. Then what is dw dt? So let me let me write the w dt, and then I box it. W with respect to t is simply 0.21. So this is this, everybody, okay? And this is this. Now, of course, we are going to put 0.21, 0.25, and 2.6 together by multiplying this one, and this one. This is what we get. Now, if we want a function as a function of t, w must be replaced with 3 plus 0.21 t, and we are done. However, Since they are asking at what rate is the length increasing when it's 100 days old, we know the length when it's 100 days old, okay, is this much, and the weight is this much. And since this just needs the weight, just replace the weight with 24, put it into a calculator, and the answer is 22.0532 millimeters per day, and they probably tell you how many decimals you follow there. Okay. Here's the second method. You find the L as a function of t by replacing W. So that means replace the W with this expression, 3 plus 0.21t. First of all, the first part, how long is the tiger? You replace the t with 100. If you go through the process, you must get the same answer that you got here. It must be identical, otherwise there is a mistake somewhere. All right, let's take the derivative of this expression with respect to t. We're going to call it dl dt or L prime of t. So it's 0.25 remains, multiplied by 2.6, multiplied by the same thing to the power of 1.6, and then the derivative of the inside is 0.21. So I'm going to recap. 0.25 doesn't change. Times, I'm thinking about this one, okay? N, that is 2.6. G of x to the power of n minus 1, in this case, it's a function of t. This to the power of 2.6 minus 1 makes it 1.6. And then g prime of x in this case would be g prime of t. The final answer, 0.21t. All right. Now, if you multiply this number, and this number, you get the same number here. And again, I want you to see this one. If right here, we had replaced the w with 3 plus 0.21t, we would have had this one. And this one, if you replace the t with 100, you should get the same answer as here. I'm showing you both ways. Now, this was simple enough that if you didn't go with the Leibniz's notation, you found the composite function, it would just work as easy. But in some instances, one is easier than the other. The amount of glass recycled in a community is G of P equals 0.5 P squared plus 7 tons, where P is the population in thousands. It is estimated that T years from now, the population of the community will be P of T equals 4.4 plus 0.1 T squared thousands. How many tons of glass are expected to be recycled 4 years from now? Again, we have two choices. G, the amount of glass, is a function of P, the population. The population is a function of time. I can replace the P here with this, becomes a function of T, and plug it in. However, it is probably easier just to calculate the population in 4 years. As you know, this is 16 and makes this one 1.6 with 4.46, and that means 6,000 people. And now you put this into this. You get, this is 36. This is 36. Half of it is 18. With 7, you get 25. And square root of 25 is 5 tons of glass. So we're done with the first part, or elementary algebra. Find the rate at which the amount of glass recycled is changing with respect to time 4 years from now. And of course, even if they don't mention it, you should include units always when you answer word problems, if units are given. So there is one point in time, and that rate means instantaneous. So you want dg dt. See, find the rate at which the amount of glass recycled is changing with respect to time. So dg dt. And so we're going to write like this: dg dt. What's in between? What takes us from G to T? In between is the P function, the population function. So dg, dp, dp, dt. Again, the way you figure it out, you're going to go from the G function to the T function. The intermediate variable is what you put here. All right. So we wanted that dg dp, that means differentiate this with respect to p, dp dt, that means differentiate this with respect to t. To differentiate this, we are going to raise it to the power of 1/2. Now we're going to differentiate this using the extended power rule. That means we put the 1/2 in front times the same thing to the power of negative 1/2 times the derivative of the inside 0.5 times 2p is p. So one more time. 1/2 sits in front. The same thing to the power of 1/2 minus 1 means negative 1/2 times the derivative of the inside, this part. The derivative of the inside is 0.5 times 2p, which is p. dp dt is just 0.1 times 2t, or 0.2t. Now, do you have to simplify this? Do you have to make it a function of t? You could do that, meaning you simplify and you replace this p with this function, becomes a function of t. But the reason you don't have to, because they want a number 4 years from now. That means they want t equals 4. But why p equals 6? Because in the previous part, we found out that when t is 4, p is 6. That's why this is where it comes from. We're going to do that. I'm going to show you. You can plug in, or you can, simplify it and do it. So let's just quickly do both. Just the way it is, if you plug in, you get half 0.5 times p, which is 6 squared, plus 7 to the power of negative 1/2 times p, which is 6.2 times t, which is 4. I hope you remember that this ended up being 25, came out as 5. And I hope you recognize this one is the same thing, but to the power of negative 1/2. And therefore, with that, it makes it 1/5. I hope you recognize this as 5. And then 1/5 because of the negative. So if we want to go with that, we have the 1/2, we have the 1/5, we have the 6, we have 0.8, and the product of those numbers is 0.48 tons of glass per year. Now, we could simplify this. Let me also show you, before you plug in, you could say this is what? A 0.2 t and p are at top. 1/2, the 2 is at the bottom, and this one is at the bottom with the square root. Please understand, this expression is this expression. And again, p is 6, t equals 4, okay? And you can plug in here. You can, in fact, say this is 0.1, and this goes away. You can do that, 0.1 pt. Anyways, either way is fine. The second method is to find g of t, meaning replace this p with this, and work on that one. This is g of t. For part A, replace the t with 4. For part B, differentiate this. So I'm going to leave it for you to do the second method on your own for practice. We want to differentiate y equals cosine to the power of 10 of sine x cubed. Please understand this is the argument of cosine. So I'm going to rewrite this in this fashion so we understand cosine is being raised to the power of 10. In fact, you can even, if it helps you, just ignore that and call it g of x to the power of 10. If you want, you don't have to. And that means n g of x to the power of n minus 1 times g prime. That's the meaning of it. So you are differentiating this. 10 sits in front with cosine to the power of 9. So 10 sits in front, the same thing. This is g of x to the power of 9 according to the extended power rule. And now you want the derivative of the inside. Now, I want g prime of x. I want the derivative of cosine of sine x cubed. Okay, so remember, somebody in fact write it in there. So I want the derivative of cosine of sine x cubed. So the derivative of cosine is negative sine. You can use this one, negative sine of u du dx. So negative sine of the same thing, sine x cubed, negative sine of whatever this is, sine x cubed. And then the derivative of sine x cubed, continuing with the chain rule. The derivative of sine x cubed is cosine x cubed times the derivative of x cubed, which is 3x. Let's recap. Let's recap. 10 sits in front, the same thing to the power of 9. Don't forget this argument must remain. Now you want the derivative of the inside. You want the derivative of this piece, which is all of this. Let's quickly discuss that. Cosine gives you negative sine of the same thing times the derivative of sine x cubed. The derivative of sine x cubed. The derivative of sine x cubed is cosine, sine. Remember what I told you? Just read sine and pause. Sine, cosine of the same thing, x cubed. Is this x? No, the derivative of that, 3x squared. You're done. You're just going to rewrite this by putting 10, negative 1, and 3x squared in front. And cosine x cubed you put in front. Okay. Cosine to the power of 9 of sine x cubed. Sine of sine x cubed. Now this one, whether you put it before or after makes no difference. But this is one way to write. This is a question you want to go over a couple more times. A quick recap. 10 sits in front, the same thing to the power of 9. The derivative of this expression, if you call it g of x, this whole thing, if you call it g of x, is this entire thing, g prime, okay? Cosine gives you negative sine with the same argument. Sine x cubed gives you cosine x cubed, 3x squared. We want to differentiate. And the first thing we are going to do, we are going to notice that this is a product of those two pieces. We put a raised dot between x to the power of 4 and e to the power of 2x. Therefore, we need to use the product rule. We are going to assume this is f, this is g. So we're going to put f prime g plus g prime f. So this is 4x cubed with the times g e to the power of 2x plus g prime e to the power of 2x times 2, right? And then times the first piece, the f function, x to the power of 4. This makes it, maybe you want to do this. Let's say this is h of x and this is h prime. So you're looking at f prime g plus g prime f. And you're done. All you have to do, factor the common factor between the two expressions. 4 and 2 is in common. X cubed, x to the power 4, x cubed is in the common, and also so is e to the power of 2x. So if you divide this piece by this piece, everything cancels out. except 2. If you divide this piece by this piece, everything cancels out except x. You get 2 plus x and you're done. All right, f of x is 9x times x minus 1 to the power of 4. And it's the product of these two. And by the way, as I mentioned, this number class, if it's large, you can put brackets here, keep carrying it as a coefficient. But it's not a big deal. You can say this piece times this piece. So it's f prime g plus g prime f, meaning we are using the product rule. And so this is 9 f prime times x minus 1 to the power of 4. Plus now this one gives us 4 times x minus 1 cubed times the derivative of inside happened to be 1. I would like to write it because it may not be. In this case, it's 1. And times 9x. Again, what you're looking at is the following. This is f prime g. This is g prime f. And we are done with calculus. Calculus is done here. Calculus is done here. Everything else is algebraic technique to simplify. So, what is in common between these two? 9 is in common. X minus 1 is in common. One has exponent 4. One has exponent 3. We choose the smaller of the two. What remains from the first one? If you divide this one by this one, just x minus 1. What remains from here? X minus 1 cubed goes away. 9 goes away. So 4 and x. So 4x. And of course, x minus 1 and 4x. They add up to 5x minus 1. We are done. And that's the final answer. Please understand, algebra, many algebraic steps. This is the only calculus step. And that's important to understand. The algebra is very straightforward, and that would be most of the steps. As long as your algebra is strong, things go pretty nice and easy. We want to differentiate this, and perhaps if we rewrite it as sine to the second power, that means sine of 8x to the second power. So according to the extended power rule, 2 sits in front, and sine 8x to the power of 1, or just write it afterwards. And then now I need the derivative of sine. I get cosine of the same thing, 8x, and then the derivative of 8x is 8. So please understand, if this is the g to the second power, okay, so this is 2g to the power of 1, and this is g prime, and we write it as 16 sine 8x cosine 8x. F of x is 3x times 3 to the power of x. We are going to differentiate, and we need to notice this requires the product rule. So if we call it f times g, that's f prime, which is 3, times g, which is 3 to the power of x, plus g prime f, 3 to the power of x. Any exponential, just write it itself. And then, is the base e? No. ln 3 by the logarithmic properties. Is the base, is the exponent x? Yes, you're done here. And then, so that's g prime f 3x. Okay, everybody? Again, done with calculus. Done with calculus. Now this has exponent 1. So this becomes 3 to the power of x plus 1 or 1 plus x. This has exponent 1. Same thing here. So 3 to the power of x plus 1 is in common in both cases. The second case, the same thing. It leaves us ln 3 and x. And of course, if I take 3 to the power of x plus 1, the first one gives me 1. The second one gives me x ln 3. Please do not write ln 3x. Write x ln 3. Okay, because this is not, notice I have erased that here. It's not ln of 3x. It's ln 3 times x. So, calculus, algebra, algebra. A lot of algebraic steps, everybody. A lot of algebraic steps. Implicit differentiation. Functions expressed by one variable are defined explicitly in terms of another variable. For example, y equals x squared minus 2x plus 1, or y equals f of x. Some functions are defined implicitly by a relation between x and y, such as x squared plus y squared equals 25, or x cubed plus y cubed equals 6xy. In some cases, it is possible to solve such an equation for y, and in some cases, it is not easy or even impossible to do so. In such cases, we can use the method of implicit differentiation. This consists of differentiating both sides of the equation with respect to x and then solving the resulting equation for y prime or dy dx. We start with a very simple example, 4x plus 2y equals 10, and we're going to do it both ways, explicitly as well as implicitly. Explicitly means I'm going to solve for y because it's doable easily. So we're going to solve for y, which means I'm going to move the 4x to the other side, and I'm going to divide by 2. And everybody knows the derivative is negative 2. It's very straightforward. So this was easily solved for y. But what if we couldn't and we want to do it implicitly? Then this is how we differentiate. 4x, just as before, 4 plus 2 plus, of course, 2y is 2y dy dx, and 10 is 0. So one more time, 4x is 4, 2y is 2y prime. On purpose, I put y prime here and dy dx here. Both mean the same thing. So 4x is 4, 2y is 2 dy dx equals the 10. 10 gives us 0. Therefore, we're going to move the 4, making it negative 4, and divide by 2. And as you can see, the two are identical. We get the same answer, everybody. The point is, you can do it either way. In some cases, we have no choice but to do it implicitly. We want to use implicit differentiation in this case, where 2x plus y to the power of 4 equals x minus 2y. So we are going to differentiate. By the way, whether you call it dy dx or y prime is normally the same. And I say normally because if Independent variable is not x. They are not the same. Okay. Sometimes it's easier to work with y prime. So having said that, I'm going to differentiate the left side, which means I'm going to put 4 in front and the same thing cubed. And then the derivative of the inside, 2x gives me 2 and y gives me y prime or dy dx. That is the implicit differentiation. 2x gives you 2. What about y? Y prime. This gives you 1. This gives you minus 2y prime. And I'm going to put the asterisk to it, meaning this is the only calculus step. And I'm done with calculus. Now I'm going to do algebraic techniques to finish the job, which means I'm going to solve for y prime. So if I multiply this by 2, 4 becomes 8. If I multiply this by y prime, this is what I get. The reason I'm going this route, because I'm solving for y prime. So this is my algebraic techniques to solve for y prime. Anything involving y prime remains. So this one moves and this one moves. Again, I want to make sure that we understand what's going on. So we are moving. This to the left becomes plus 2y prime. This to the right becomes negative. Since we are solving for y prime, on the left side, you want to factor out the y prime. And when you do that, notice what happens. When you factor out the y prime, you get this one, okay, times 4 without the y prime. And this one just gives you 2. So what is y prime, the right side, divided by the brackets? You call it y prime or dy dx, makes no difference. Sine y plus 2x cubed y squared equals 6. We are going to differentiate this implicitly, and we notice that this one requires a product rule. So sine y is cosine y dy dx, or y prime. 2x cubed gives you 6x squared times y squared, plus y squared gives you 2y dy dx, or 2y y prime times 2x cubed. Any number gives you 0. And again, you're done with calculus. The point I'm trying to make, class, not a lot of calculus steps. You're solving for dy dx. That means anything involving dy dx remains, everything else moves. But anyways, let's combine these two into 4x cubed y. And now let's move this. Now, to move this becomes negative on the other side. And since you want to solve for dy dx, these two, if you take out dy dx is cosine y plus 4x cubed y. So these two factor out dy dx. This one move and make it negative. Divide by the parentheses, and that's dy dx of y prime. That means dy dx is negative 6x squared y squared, the right side, divided by the parentheses cosine y plus 4x cubed y. Here's the last question. We want to find an equation of a tangent line at the given pair for the given relation. First and foremost, you need a pair, it's given. You need the slope. That means you have to find y prime or dy dx. And to do so, we are going to put a raised dot here and here, and we're going to differentiate implicitly. X gives you 1 times e to the power of y, plus e to the power of y gives itself e to the power of y times y prime, and then by the product rule times x. So that's the first part. Now we go with this one. Y gives you y prime times the second part e to the power of x plus e to the power of x gives you itself e to the power of x times y, and any number gives you 0. You're done. This is the only calculus step. Everything else is algebra. Put the asterisk next to it. This is the only calculus step, class. This is the only calculus step. And so, what do? We want to solve for y prime, which means these two pieces that contain y prime we take out the y prime, we factor out the y prime, and this gives us e to the power of y times x, or x e to the power of y. This gives us e to the power of x. And they just move to the right, each one becomes negative. We can put a negative in a parenthesis and put it there. So y prime is the right side over the parentheses. What is the slope? Evaluate this at this pair, and it becomes the slope of a tangent line at that point. Evaluate this given the pair. So replace the x with 0, y with 1. And when you do that, of course, this is 1. Of course, this is 0. Of course, this is 1. So the denominator is 1. And the numerator we get minus e plus 1. So we can use y equals mx. So it's minus e minus 1. And we can use y equals mx plus b because this is b. So we get y equals minus e minus 1 times x plus b, which is 1.